All right, perfect. So today could you just quickly introduce yourself?
Okay. My name's IK. I'm a computer engineer. I do electronics, firmware, type of thing. I have an interview coming up soon, which is why I'm trying to practice for it. It's also in the so software. Oh, it's not software engineering. It's also in the firmware engineering kind of space. So I know it's not kind of what you're used to, but
Mm-hmm.
I just it's still a leak code style question, anyways. It's just not anything super complicated. Like it's more like hash maps or
Hash maps.
basically the basic stuffs, right?
Really?
Not none of those graphs or like a lot of linked lists, arrays, hash maps, strings. Uh,
Is it more practical or just or random leak code question that has a small trick to it?
well, actually, the ones I've been doing are actually very practical. So I know Amazon um they do more like legal style questions, right? Where um where you're implementing an algorithm and then you have like, oh, this algorithm is this time complexity. But the kind of problems I've been faced with so far for this company is more like a um how do I explain it? It's more like how it's more like you have this so an example was two processes, they're trying to two threads, right? You want to use spinning of two threads and you want to print the thread ID of the other guy of the other thread,
Yeah.
right?
So it's a concurrency type thing.
Yeah,
Concurrency type.
so that was concurrency, but it's usually more like practical stuff, more not an algorithm, but just more like an idea. Like, can you solve it? So for that one, you'd have to
Okay,
set up like a mutex, and
I
then
see.
everybody will wait on the mutex, and
So how many leak code questions have you solved?
like 150.
Okay, how are you with the different aspects like arrays?
I'm good with pretty much anything except graphs, though.
Just not
I have
graphs?
I said except
Okay.
graphs.
Because
Yeah.
graphs are a big portion of the leak code questions, but we'll try to stick to arrays for the first one.
Okay.
Um, let's come up with a good one. We're gonna do one that's more of a design question.
Okay. Yeah.
We're gonna do. You're
Yeah.
probably familiar with this one. So my friend is shadowing me. He's gonna be doing interviews soon too.
Okay.
Um, design.
Yeah.
So I just want to just get a hold of your sort of. This is gonna be more of practical, but we're just trying to get a sense of your programming and object oriented skills. What programming language are you gonna use?
Um, I can do Python. Yeah.
You're gonna use Python.
Yeah, that's fine. Usually, I just change based on the difficulty of the question.
I see. Okay.
But I think for this one, I can do all Python. Usually, yeah. For my interviews, I do everything in C because it's supposed to be like an embedded
Yeah.
uh, problem.
So for this first question,
Mhm.
we're gonna be designing an underground railway system. And
Okay.
this is just the first question. We might get into more, but
Okay.
let's see. Let me
Um,
quickly.
yeah. Actually, before we start, I wanted to say thank you though for doing this.
No problem.
Yeah, I know it's a lot, and especially for free, that's insane. So I just appreciate
Yeah.
that.
Thanks for hopping on. This is fun when we get people who are doing cool stuff, hopping on and we get to see their thought process. So it's important. We get to share.
Mhm.
Uh, like how many people have I interviewed now and so many different solutions and so many different levels. So you get to see it. So here I'll send you the link. Take a
Uh,
read of that question.
Coder path. So, what about you, James? What do you do?
I do. I'm a software engineer. Pretty traditional software engineer.
Okay.
Yeah. Work at pretty much the application level. A lot of full stack. So do front end, do back end. Like what? Pretty much. I've worked at all size companies. So you pretty much just do whatever needs to get done. You focus more on sort of what business problems you need to solve, and then you just figure out what you need to get done there. It's not like, oh, I'm just gonna be picking up front end tasks or picking up back end tasks, or it's more like how does work come in? It's like we get there's a business need,
Yeah.
and all of a sudden that business needs come to you, and that business need could be anything. It could be literally on the front end. It could be the front end and the back end. It could be optimizing, um, like some database performance issue, and that could be on the infrastructure. It could be in your database. It could be in like your wacky code, just the way you queried it down. It's like it changes. That accurate?
Yeah.
Brian?
Yeah.
All right. Are you in here? I sent it to you. Oh, he dropped out? Wait just a sec.
Just two.
Wait, the guy dropped out. Where's he at? He's lagging. Give me a sec. All right. We're given a simple. What we're gonna do here is we're gonna design an underground railway system that keeps track of a customer's travel times between different stations. They're using this data to calculate the average time it takes to travel from one station to another. We need to implement 3 functions: a check-in time, a checkout time, and then another function called get average. So 3 functions.
Okay.
So basically, check in, you take in an ID of the person who's checking in. You take in a station name, which is the starting station name, and then the time that they checked in. Right? And then later at some point, that person is going to check out at some station name
Mm-hmm.
at a specific time t. So get average time, we should be able to ask the system, what's the average time it takes to go between start station and end station? And like the reverse isn't true. It's like it's unique to the start and end station here. I think it says right here.
Oh, you said the reverse isn't true?
Yeah, it's not just because it takes an average 10 seconds to go from start station to end station doesn't mean that it's gonna take the same from go to end to start, right? It says right here. The time it takes to travel from start station to end station may be different from the time it takes to travel from end station to start station, like the reverse. So, yeah, you may assume that all calls to the check-in and checkout methods are consistent, and if the customer checks in at time T1, then they check out at T2, where the T1 is less than T2. All events happen in chronological order. So I'll let you go ahead and figure out what's happening here.
Okay. So question seems very detailed, so I'm have to read it a lot.
Sure.
I might not have any questions. So I see that the customer can only be checked in at one place at a time, which is good. So that means we can actually use a map. So we can map the ID to the station that the person is in right now. Actually, we want to do the other way around. Let's see, because we need to have the average. Maybe we have two maps. We need to have the average time. So, okay, how many um how many sorry people are going to be using this train station?
How many people? A lot of
Mhm.
like unlimited people. It shouldn't be a limit.
Unlimited people. Okay,
Should be
so
a
I shouldn't.
lot.
Okay,
Yeah.
okay. So definitely, I have to hash the ID. That's for sure. And it's a unique ID, right? So essentially, one person has that one ID for the whole duration of.
Yes.
Oh, okay.
Well, not one person. Well, I guess yeah. We could say the ID is unique too. One person. Everyone's gonna use their own ID, have their own ID.
Okay.
Yeah. Yeah. It says right here, a customer with a card ID equal to ID.
Okay. Let's see. Can I get average time from start station?
after?
I'm down.
After this?
Okay, and what about the stations? Are there a finite amount of stations?
Not finite. We shouldn't assume it's finite. There could be a lot of stations. Or let me ask you this: how is that going to affect the solution if there's finite?
So okay, so because I'm thinking of essentially anytime somebody checks in, right? I store. Actually, I don't. So I was thinking of having like a 2D array, right, of each station, right, from station to station, and then store the average time in that 2D array. And anytime someone checks out, I update the 2D array with the check-in time and with the like the average time, like
Could
t2
you
minus t1.
explain a little further what you mean by 2D array of the station names? Oh, so something like station names is this 2D array where you have like the names like A, B, C. These are stations A, B, C. And then over on this side, you have A. You have station B. You have station C.
Yeah,
You have
just
station,
like that.
yeah, something like this.
Yeah, and then each value stored at that station would just be the average time
Okay,
for that station.
pretend we had a very we had maybe even just 10 D, A, B, C, D, like all the way to like Z, right?
Uh-huh.
All the way to Z, and then only one person. Only one trip happened from A to Z, so we have this massive array of data, and we only have like one entry there. So I think it's not that efficient on space.
Yeah. Okay. Because the other idea I was thinking was a 2D map,
2D
but I've
map.
never heard of that before. I don't know how, like basically the same thing but just with a map. Does that look feasible? Right, we have like the stations, and then it's just if it's Python, just something like this. It's a map. It's a map of maps, a dictionary of dictionaries, and uh, each station is like A has its own dictionary, and B. I guess that works too.
Then what happens in here inside? It's like, does A B here mean that they entered in A and left in B?
Yes. Yes. Sorry, I need to be more explicit. Yeah.
Yeah.
It means that they entered at A and left uh at B, and then we'll have since each person can only do. Okay. So another question I have is um
Mm-hmm.
someone else can check in after that person, right? That's
Wait, could you
obviously a
repeat
given.
that again? You
I'm
cut out.
saying if I checked into station A
Yeah.
at time 1, somebody else can check into station A at time 2,
Yeah,
right?
like somebody can check in after me, but I can't. We could assume that the input is well formatted. Like I'm not gonna check into station A then check into station C at the same time
Yeah, yeah,
because you can't
yeah.
teleport, right? You need to check into station A, then you need to exit, and then you need to enter again. We could assume that it's well formatted in that sense.
Okay. Um. All right. So this is what I have for this, right? So we'll have the stations map, and then we'll also have like a user location map, right? And then basically, uh, uh this maps to probably a tuple, and the first thing is the station name, So maybe like station A, and the second one is the time they entered.
Okay.
And this is just the check-in location, right? And then when you check out, uh actually, since you can only be in one place at a time, we don't need to store the. Well, actually, no, never mind. We do because we need to use this A to get the average. Okay, so essentially, when you check in, you put the tuple in the user location. When you check out, you remove it, and then so this is T1. Right, check in is T1, and then when you check out, you remove it and you say something like, uh, this actually might be tough. I'm trying to get an O of 1 average. I think that's kind of what I'm thinking because I want this call. I'm trying. Maybe I'm because I'm thinking of the optimal solution too early. I want this call get average time to be O of 1, and
Okay.
I'm essentially that would mean storing the average in this station's thing itself. But that might.
Sure. Let's just yeah. Let's make sure it works over one. I mean, what would be an unoptimal solution?
An optimal would be probably to store an array here of all the times, right? You can store this person's T1 minus T2, or T2 minus T1, and then store another person's T2 minus T1,
Sure.
right? And every time, so we just store these values in the array, and anytime you call this, you then call the average on this guy every time.
Mm-hmm.
So, right, that works, but I think we could do better.
Yeah.
So it does mean that okay. So
No.
do I have to implement this or is it just more like a
No, you have to implement it. You have to implement it.
okay. Do you want me to kind of
I mean, how can we make that faster, right? Pretend we have a bunch of A and B
Okay.
and that list is big and the person and we just keep querying the same average time for that start and end station. We query it a million times. It's
yeah,
slow, right?
so we have something called a running average and that's what we'll use here.
Okay, sure.
So the first value would be the actual average. So I'm going to store a tuple instead now. Or maybe yeah, a tuple is probably best. An average and then here would be the n, right?
Mm-hmm.
Um,
So how do we calculate the average using average and n?
actually, no, sorry. I think an easier way, instead of storing this average and n, would be to store the sum and n. Right. If you wanted to store average and n, it's not. It's possible. You have to do like average times n, then plus the new value. I guess I can do that too. Sure. And then you divide it by n plus 1, and then you increment n. Yeah, let's do it like that.
I mean, let's
Right.
just isn't it easier to just calculate have the total sum and the number and then just divide it or
Yeah, that's what I was
Yeah.
saying. It's just easier to do it like that. Yeah, rather than doing all this fancy math.
yeah.
Sorry. Sometimes I get ahead of myself because like in Python it's okay, but what if the sum is greater than like I don't know 32 bits?
Like it overflows, right? Yeah, that makes sense.
Yeah.
So how would your other solution stop that? You're multiplying averages by
Well,
n.
um, that's actually that's true. Yeah. Okay. Good. GG's. Yeah. 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 That makes sense. I didn't
Like
catch.
it could. I'm just wondering. I'm just trying to see.
Yeah. Now that
Average
I
n?
now that I think about it, I don't think it's possible. Yeah.
It depends on your
I,
calculation, but
yeah.
it is something you worry about if it's gonna overflow. But you're using Python here, so if we're using
Mhm.
C++ or Java, then I would say worry about it. But we're using Python.
Yeah. Okay. Uh.
Okay, so what are you thinking for the solution? That's the user location. You
Yeah.
okay? You calculate the average time. Yeah, just go
Um.
ahead and implement it now, so we can move on to the next question as well.
Okay. Sounds good. So for the
What are you
check-in,
thinking so far?
Or
Man, he
check-in
suggested
is
you go to
zero.
brute force solution first. Optimize later.
So I'm just looking at the thing. Check in with ID string and then the time. Okay.
Okay, we want to follow like object oriented principles too. So,
Okay.
please break it down into like object, like a class and stuff.
Okay. Um. Okay. It's looking like there doesn't need to be a constructor for this. I don't like. Is there going to be a constructor for this class?
Okay. I mean that would be a question for you. When would we need to introduce a constructor or not? Like, what does a constructor do in an object-oriented sense?
It sets up the structures that we need. Um, I guess I will need one. My question was more like, is there something that we need to the caller to pass to this railway anytime they initialize it? But since you said that everything is infinite, right? In the case,
Yeah.
maybe you could pass like, oh, the number of railway stations we have, or a, a list of routes, right? You can only go from A to
I
B
mean,
from.
it makes sense, but all I would say is, yeah, it's you're designing this thing. So if you want to decide to add stuff, you just let me know, and I'll agree with
Okay.
it or not. Because yeah,
Okay.
I want to see what you're able to create.
Sounds good. So I'm just going to initialize the. Oh, sorry. I don't really know Python like that. Initialize all the stuff we need, like stations, user location, and all that stuff. Stations. Actually, I'm gonna call it station average. So station average is it's a map of maps. I don't think so. It's a map,
Open on this one. Show your face.
and then
Just thinking about the problem.
the user location self dot user location is another map. So 2 maps. I think that's all we need. And on check-in, essentially we just
You get what it's asking though. The
add
question.
Yeah.
You read it. What do you think about his solution so far? Is it making sense? Like,
station.
I'm a little confused. Wait, let's see. Hash map of hash map.
that part is we definitely could fix that.
That's- So I think station.
Okay. So they add the user ID and location. They check in.
Mhm.
Makes sense. Okay.
And then for the checkout, same thing here. ID. I think checkout also has the station, right? Yeah, it does. Station and time. Self dots. So then here, this is where we would have to so I can get the huh, station. Okay. Station name and check-in time. I don't know how to pop stuff from Python
How to pop stuff?
dictionaries, right? If I let's say self the user location. So how do I like pop? 'Cause I don't need it anymore. Right? If I want to
User location.
so I want this ID, but I don't want to just read it. I want to pop it out.
Okay, I'll just give you the. If you want to delete it, you can just do delete.
Oh, okay. Sounds good. Okay, so station name, check-in time is self.user location ID. So we're taking the name and the time. I don't know why it's grayed out, but hopefully that's not a bad thing. So we take the station name and the check-in time, and then essentially in this user location, in the stations, we then want to take the station. Oh, so I want to change this from um station name to start station. So this is a start station, and this I'm just gonna call this the end station. Um, then stations from self the stations average from the start station to the end station. Um, uh, um, um, sorry, hold, hold. So just read that, and then I see uh, self dot station average from the start station to the old station to the end station is equal to uh, so it's a tuple. The first location. Well, okay. So if I guess we have to first check if these guys are in there, right?
Start
So
station, end station are in the station average. What
yeah,
would happen
yeah.
if it wasn't?
Well, it'll crash with a key
I
error.
see.
So and this just means that maybe this is the first time the user is taking this route, or first time anybody's taking this route, a lot of stuff. So maybe instead of doing that, I could do um I can first of all check if the start station is in the self dot station average. I guess I can delete this one. Um, and here, if also the end station is in self dot station average start station. But I want to have a default value here. So old val is then so the default sum would
Okay,
be
okay. Let's think about this. Like, is there a better way to do this than the double map? Like, is there a way
um
that we can generate a key to the map that it doesn't include us creating a double map?
uh yeah, maybe you could concatenate the start and end station together.
Yeah, that'd be
Uh,
better. I think
okay,
it would just make it more simple.
okay. Uh, it just feels like it's gonna take some time though.
Okay.
Maybe not. Okay, let's do that. So so then I can say something like um station value is like the station average that gets, and then I can get this before I do that. I want to say the key is start station plus just want to add like a plus in between it. Uh, end station. Okay. Then key. If not, we want a tuple that is 0 0. That is
Mm-hmm.
yeah, no sum and no travels here. This should be stop that station connection. Okay, and then now I can say that at this key. Yeah, thanks for that hint. I don't know how I got like tunnel vision. I couldn't really
No
see.
problem. It happens.
Okay. So then set the station average key. Yeah, and then it's pretty simple. We just want to take the station val. Just gonna station val
What are you thinking so far?
uh, 0,
I would
1,
not have solved this on my first.
and add. Actually, maybe I should have it take the sum and n, s and n. Then just take s plus what's the first? So I want to add. I want to take the time it takes. So that's um time minus the check-in time, right?
Okay.
And then we just take this n and we do +1. Okay. And then when we define this get average time um, from the start station to the end station, start station, end station, we essentially just return. Also, I need to put self here because essentially just return, say the key, copy this guy. Same thing here. And then they say, so I'm not doing any checks because I see that in the um, code it says that
It needs to
would,
be. It's gonna be well formatted. So
yeah,
yeah.
exactly. So I'm not really doing any checks. So key start station with end station, and then essentially I just want to return. I want to take the sum and the n, and then it's just equal to self dot station average at this key, and then I just want to essentially return sum divided by n. That's the average. Uh,
Okay.
so
Makes
yeah,
sense.
does this look good?
Let's run it out on some test cases too, or let me run it on this test case that I'm gonna send you.
Okay.
Actually, I know it's good. Let's move on to the next function that I want you to implement. So I'll
Okay.
implement it at the bottom here. But I
Okay.
want you to implement. Get me the last k travel times.
Oh, okay. And everything is the same.
So what's gonna happen is we're gonna in our railway we're gonna be inputted some k, and k is gonna tell us is the k for this function get last k.
Okay.
So what this is gonna do is this is just gonna tell us the last k travel times in the whole system.
Okay. So travel times, what does that mean?
So pretend someone went A to B.
Mm-hmm.
Let's say k is equal to 2, right? So k what we mean is we want to pass or return the last two travel times. So if the last two travel times were AB and then AC and their one was 4, one was 10 seconds or whatever time
Okay.
or unit, we just want to return these last two. Does that make sense?
Okay. And the 4 and the 10 is basically this start time,
In
end
an
time, and a start time.
it's just telling us the last k travel times, as in how long did it take.
Okay.
Yeah,
Okay.
yeah, length of trip. Get the last k travel times in length.
The end of the length of
So
the.
if A to B took 4 and A to C took 10, and those were our last or the last trips that happened, it would come if it was in this order 4 and 10. Like 10 was the very last one and 4 was the most recent one. That's gonna be the result here.
Okay. So does it have to be in any order?
It needs to be. It doesn't really need to be in any order, but we just need the
Okay.
last k travel times.
Okay. Sounds good. Seems like we want a queue of some sort, or um, yeah. Let's see. Um, so essentially, we just want, I could say, an array of the k most recent travel times. That
Pardon?
sounds
Yeah, the K most recent travel times.
okay. Uh, I'm thinking of using a queue, and I just like a double-ended queue, right?
Sure.
And I add to the end and pop from the top, and that type of thing, right? And the most recent one will be added to the end, and then if we're more than k, we pop the top one. So essentially, it's a queue that only has k items in it. Uh,
Okay.
that sounds good.
Sure. Yeah. Go ahead and implement that. Sounds about right.
Okay. I know Python has a double-ended queue thing. Trying to see if I can remember how to. No, I have to import something. Like import that queue. Was it smaller? Nope, I don't remember.
I'll do for you from collections.
Okay. Okay. Thank you.
No problem.
Um, Question input queue. Actually, uh, I see. Just trying to remember the format on this. So that's the queue, and then that's the. Okay, sounds good. Um, so this is going to be our self dots. Uh, um,
What
our
are you gonna do here? K
start
equals.
A, and then self dots uh, recent times. And it's an array, which is our double-ended queue. And then basically we only know the times when we check out. So in checkout here, uh this is where we'll do the magic. So we can do like a self the recent times, the append um second. Okay, how do I, so I know I appends to the end.
Appends it to end.
Oh
And
wait,
then
that's not
we have a pop left to get from the start.
okay.
Or from the pop left is the start. Um, if you want to add to the end, you could do append. Pop left to remove from the left side.
Okay, thank you. Append is we append to this queue self dots um recent times, and we're appending this time minus the check-in time. And basically, if length of the self dot recent times is greater than k, then we pop left the queue dot pop left. Hey, is that right? Pop
Or
left.
I'll just fix this up for you a little bit. Like the API is more like you create a DQ like this, and then you go
Uh,
self dot recent times dot append, and self dot recent times dot pop left.
okay. I thought it was more like the heap thing because I know.
Yeah,
Okay,
yeah.
self the recent time the pop left, and then we pop just anything really, yeah. And yep, and then in the function get k last travel times. I guess we can just return if we want it as a list. Maybe we can return this list of self dots k get k last travel times. Wait, sorry, I don't know why. Wait, what? Is it because? Oh, it's called Recent Times. There you go. Yeah,
Okay.
that sounds like what it looks like, right? That sounds like yeah, that sounds good to me.
Okay. This one we could just talk about for a few minutes,
Okay.
but what if we want to get the K fastest trips?
Okay, fastest trips. Um. Okay, yeah, we could use a heap, something
Okay.
like a min heap, and so it'll be pretty much the exact same thing.
Yeah.
But instead of using a double and a cube, just use a min heap.
Yeah. Okay. Cool.
Yeah.
Sounds good. All right. How do you think you did?
I think I was a little rough, choppy. Definitely didn't really know much Python. I'm not sure if I communicated well
Yeah.
what I was doing. Um, yeah.
Yeah. Brian, what do you think first?
Yeah, I think you did well. Maybe a little slow at the beginning, but once you start programming, went well.
Yeah. That's my friend. Big
Yeah.
what 12 hours crazy work. Yeah, I would say just the main thing is just speed here. Like you clearly understand heaps, you understand hash maps, you understand the syntax, you able to do the math, right? But I would just say that you should focus on pumping out these questions a lot faster. So getting this question done within 20 to 25 minutes would be my goal. So we can move on to another question. So I think it's all about just working at a specific or at a really or a much faster pace. I would say try to work at 2 times the speed you're working at right now because that's like the pace that people would expect at an interview as well. Because pace also matters when it comes to getting the job. If you do this question, honestly, the question is like pretty straightforward. So
Hmm.
I would expect most candidates to solve it. But then the part that I would judge them on is how fast were they able to solve it, and how many mistakes did they make, and how optimal is their solution in different areas like that. I think, yeah, I think you have all the fundamentals there, but it's just working on the speed portion of it.
Okay.
Yeah. Why do you think it was a reasonable pace or no?
Oh yeah, yeah. I don't think it was a reasonable pace. I don't know why I was typing that slow. I have no idea.
No, it's no
Maybe it's
problem.
because I'm trying to talk.
Yeah.
I don't know what I'm supposed to be saying and what I'm not supposed to be saying.
Yeah.
Um,
Like I think honestly, these
mhm.
days a lot of the companies are testing how fast can you come up with ideas and then implement it, right? Isn't that in the criteria in a lot of
Yeah.
them? A lot in the
Okay.
companies that I had to interview or I had to run interviews for. We care how fast that they do it because they want people who can think really fast and come up with solutions really fast and implement really fast. It's like speed is important as well, especially when you have 10 different candidates. If this question at least 6 or 7 are gonna solve it, and then now I need to see who came up with the solution, who came up with their ideas the fastest, and who was able to iterate through the ideas the fastest, who was able to write the cleanest code, etc.
Okay.
Yeah. So I think you have the fundamentals there. So one, I would suggest just timing yourself when you do questions, and just try to work at a faster pace. And it might feel uncomfortable at first, but you need to sort of push yourself when you're doing the questions as well.
Okay.
You could get through more and more questions. But yeah,
Will you say that like the time it took me to get to the solution was slow too?
it
Like
took a
too
while. It
long?
took a while to get to the solution.
Yeah. Okay.
Um, I don't know. I'll have to watch it over. But a lot of the times, yeah, we would just expect to get you to the solution within X amount of minutes, usually 10 to 15, and then implement it in another 10 to 15, and then start working on more complicated follow ups right away, or start working on the next question. But yeah, that's kind of that's my advice. I think you're doing good. You understand the fundamentals. I would just make sure to just lock in more of the if you're going to be using Python as your programming language, understanding more of the language specifics,
Hmm.
like building building the keys to the hash map, right? You could have also just stored it as a tuple, because tuples are serializable, so you could actually use that as keys in the Python library, or as keys in the Python dictionary. That's one thing you could have done. So little small things like that, language related, would go a long way too. And then yeah, because I know you said you don't use Python that much.
Yeah.
Yeah. Cool. All right. Thanks for hopping on for the interview.
All right. Thank you.
All right, thanks.
Thanks. See ya.
See you.
Mhm.
Damn.
Damn.